Hey guys, this is compilation of the problems we covered in the first week of our end decoding challenge. Let's start. So the very first question that we discussed on day one was two sum that is present on lead code, and it is one of the easiest questions if I not say not one of the easiest, but yeah, it's quite easy. It's quite an easy question, and actually there are two variations of this question. The very first time that I read this question was I thought it is the more famous version of the variation that we worked on, in which you don't have to return the indices of the indices of those particular values which add up to the target, but you have to return the actual values. So that in that case that is a little different, that have a little different implementation, but yeah, we encountered this question and this has its own implementation. Okay, so it's actually quite easy. It's not very difficult. So you just have to find out the two elements in the array that add up to this number and return the indices of this element. So for example, 2 and 7 add up to this, so you have to return 0 comma 0 1 2 3 to 0 comma 3. So 0 is the index and third index. Okay, and the n square, the omega of n square complexity, the answer solution for that is very easy. It's a greedy solution. You just keep comparing two elements, 2 with 11, 2 with 15, 2 with 7. Yeah, with 2 with 7 is the answer, but yeah, for example, you will keep on comparing 11 with 15, 11 with 7, 15. So this is a greedy implementation that you check each and every pair, that if it adds up to the target or not, then you'll be able to find your answer. But that takes that you have to take n cross n times. You have to traverse the arrays, so that will take O of n square of complexity. To do this in O of n time complexity, we have to use a data structure called hash map, and in hash map we'll store the values of the arrays as key and the index of that particular value as the value of that key. Okay, so do not get confused with this statement. I'll not try to confuse you, but yeah. So the indexes of the values are the values that are stored against the key, and the keys are the actual integers that are present in the arrays. Okay, so for 2 is at 0th index, so the key is 2 and 0 is the value of this key. Okay, similarly for 11 the index is 1, for 15 the index is 2, for 7 the index is 3. Now, why we want this is because the solution, we want a solution for this. So, what we'll be doing will the from the equation itself, right? So, some of these two indexes will add up to the targets. For example, 2 plus 7 is equals to 9. So, 2 minus 9 would equal to 7. So, I just have to search for the, I'll just traverse this array once, and I'll search target minus that value at each index. So for example, line minus 2 would be 7, and I'll search 7 if it exists, if it is somewhere in the map or not. 7 is there, and I'll find that it's at index 3. So I'll return the value at I, that is the 2 and the index 3. So that will be 0 comma 3, index 0 and index 3. That will be our answer. So that is why we have created the map, so that we can get the index of any of target minus nums at element at I in O of one time. Okay, so pretty easy question this was, and its solution is also very easy. Okay, I think I've opened in what one. Yeah, sorry about that. While recording, it gets a little slow. Yeah, so very easy. Here I'm just creating the map that I was showing. I'm just creating the map. The key is the value of the array, and index of the array is the value. It's a little confusing statement again, because we do not have much words in English. But yeah, this is the way. And here I'm just doing the same. I'm just searching for target minus numsci in the map. If it exists, I'm just returning the ith and the index. That index is the index for the target minus numsci. That will be our solution for that. Okay, it's a very easy question. Let's move, guys. Okay. So the next problem was, yeah. So the next problem for day 2 was valid parenthesis. Valid parenthesis. This is the easiest version of this particular kind of problem. There are a lot of problems based upon this particular set only, in which you have to validate parenthesis. But this is the one of the easiest kind, in which we have given three rules, that if the starting index is an open, the closing index would have been of the same format. For example, if it is a round bracket, closing would have should also be round. If it is square, closing should also be square. Sorry for the noise. My AC makes this noise every time. But yeah, if it is curly brackets, the closing should also be curly. So whatever you are opening, closing should be same. Point number two, I'll just bring in this. Okay, here the rules are written. Yeah, open brackets must be closed by the same type of brackets. Very nominal, simple rule. I understand. The actual point where you will understand like what you have to implement is the second point, which says open brackets must be closed in correct order. Now, what this means is that if I open some bracket, for example, first it is um, round brackets, then it is square brackets, then it is curly. Okay. Now now you see I have the last bracket that I've opened is the curly, so I'll close it. The curly will be the one that I'll close first. After that, I before that I had opened the square, so the square one will be the one I'll close first, and then in the end the round bracket, because those were the first one I've closed. Okay. So this is following last in first out rule. First out rule. Okay, last in first out, and we have only one data set that helps us to do that. It's called stack. So it's a very simple implementation. You will just, sorry about that. Uh, oh, so sorry about this choppy animation. It gets this laptop is very slow actually. It gets even slower when I start using this recording software. Okay, OBS. So we'll just, whatever open brackets we'll encounter, we'll just push it into stack. And as soon as we'll encounter a close bracket, we'll compare it with the value that is at the top of the stack. If those two are matching, if they are in pair, for example, if the if the value, opening value is this and the closing value is this, that means the value at the string that we are taking is this, and the value in the stack is this. Then we have a match, and we'll just pop the value, and we'll move on with the comparison. Again, for the other pairs, it's the same. If with some point the values does not match, then definitely our string is not valid, because it has uneven format of opening and closing of these brackets. Okay, so we'll just return false. For example, if all the values are kept on matching and we reach the end of the string, then in the end we'll check if the stack is empty or not. If stack is left with some values, then definitely we have some open brackets that are not closed. String is again invalid. But if stack is empty, then definitely all of the open brackets are closed. Then our string is valid. Okay, very easy question, not very difficult to understand, and again very easy implementation for that. Same. I was talking about implementation for that, right? So you can see. Sorry about that. So you can see we create a stack in the very beginning, and then we in a single for loop we are doing all the operations, and we have defined, right, if it is a this else statement is taking in for the whatever open stack will get, it will just push it into stack. And these three statements cover the three kind of brackets we're dealing with. If it is closed, then we'll check like if the top one is this only, then if the top one is not this, then definitely the string is not valid, will return false. Else we'll just move on with the comparison. So same all for all three cases. This is for round, this is for curly, and this is for square one. And in the end, we're checking if the after the comparison ends, we'll checking if the stack is empty or not. If it is empty, we'll return true. And if it is not empty, then definitely will return false. Then our string is not valid. Okay. Let's move to the next question. Oh, sorry for the choppy animation again. Okay. So this is the third. This is the question we covered on day three. It's called merge to sorted list. What do we do in this question is that you might have heard of algorithm called merge sort, right? So what do we do in merge sort? We break down the break down the array, because we implement that in array, into singular elements. So we break down the array into single element arrays, and then we merge the arrays. And during the merging itself, we decide, right, which element will go first and which element will go last, depending upon how we are implementing the sorting, ascending or descending. Okay, so this particular question is kind of a half implementation of that same problem in terms of linked lists. We are given two lists which are sorted by themselves. Okay, these two lists which are in input are sorted, and we have to just merge this into a bigger list, which should also be sorted. Very simple, very simple question. We'll just place 2 pointers here. Whoever is the bigger value will just in the beginning will choose any one of these value as head, and whoever is the and then we'll move the pointer to the next, and whoever is the will be the bigger value for the pointers after that. We'll just keep adding it to our answer array, and in the end, whichever list will be left out with the elements, one will definitely get finished first. For example, all of the elements of one of the lists will get used first, and other list would be left. We'll just copy all of the elements into the answer list after that if one of the list gets completed. Okay, it's a very simple implementation, and since this is a linked list question, so that's why it during implementation this looks a little daunting, because the implementation of string based questions is linked list based question is very big, right? Because we have to deal with a lot of pointers. We have a head pointer, we have a pointer for comparing, and then we have to in beginning we have to search for the check if the list is null, any one of the list is null or not, then the other list will be automatically will be the answer. Then we have to choose the head. So a lot of cases and a lot of pointers we have to deal with. That's why this solution looks very huge. But technically, this is just the implementation of the merging part of the merge sort algorithm. Since just is that it is being implemented on a linked list. That's why it looks quite huge. And in the end, we just return the head of the answer linked list will be the same as the one we have in for the normal pointer. Okay. So not very easy, because you have to understand how linked list and pointers work. But yeah, it's not difficult. Like, it's an easy level problem. You just need to understand how linked list works and then how you move across linked list, and you'll be able to solve this very easily. Okay, let's move. So this is on day 4. Okay, this question is called valid palindrome, and this is one of the very easiest questions which I have encountered till now. And you have just given a string, and you have to check if the non alphanumeric version of that string, non alphanumeric and non uppercase version of the string is palindrome or not. So the very first really sorry the very first step you'll be doing is that it converting the string into this string. So all the uppercase letters will be converted into lowercase, and the non-alphanumeric characters will be removed. So this space will be removed, this comma will be removed, and this space, all this space, this colon, everything will be removed except the alphabets, and all the uppercase ones will be converted into lowercase. So sorry about that. Yeah, all the uppercase characters will be converted into lowercase. Okay. Sorry about the noise. So after this conversion, what you will do is that you will just there's a very easy way to check if any string is palindrome or not. You'll just put pointers at each end, and in technically during implementation you don't have to even put the pointers. You'll just start a for loop with, and you'll just compare 0th and n minus 1 minus the ith element. That means n minus 1 minus 0, that is the ending element. Okay, n minus 1 minus 0 and n minus 1 minus 1, that will be this. So in a single for loop, you can complete comparison from this to this. So definitely this string will, you don't have to traverse whole of this string. You can just traverse it till half, and by that only you will get to know that if this is palindrome or not. In case of odd number of characters, you will your I and j your pointers or your comparators will reach the middle, and in case of even elements, they'll cross each other. That means one will be here and one will be here, and so that you have to decide by that how you want to stop the comparison. Okay, and once you'll reach that, then definitely you'll know your string is palindrome. And if any where in between that, if you have two different kind of elements during comparison, then definitely your string is not palindrome. uh, the implementation of this part is actually very easy, not very difficult. You can do this using for loop, but you have to understand like how you'll gonna convert this string into this string. Okay, it's not very easy, but you have to understand how ASCII works. Okay, ASCII you might have heard that. So we have to make sure that only the alphanumeric characters pass, specifically alphabets pass from the original string. So we'll just use the ASCII range for lowercase characters and uppercase characters, and we'll just convert each character into its ASCII value and check if it lies between the ASCII range of uppercase or lowercase characters. If it does, I'll store the lowercase version of the same alphabet into our answer string, and that's why we'll in the end we'll get a string something like this. Okay, and after that, like to check the palindrome, we'll just run a loop till half, and we'll just keep checking the values at each end, and if any one of those values are not same, we'll just return false, and if all of them are same, we'll reach the end, and we'll return true. Our string is palindrome. Okay, very easy question. You just have to understand how ASCII works to convert this particular string into this string. Okay, let's move. Oh, this is very slow. Yeah, best time to buy and sell stock. This question actually is not an easy question. Actually, the I one of the guy has come one of our one of the guy has commented on the reel for this particular problem. Is that this question, like, definitely no, the way I have implemented it, no one thinks about the same implementation during the first time, because in the first step itself, this question looks like that this is a DP problem, and you have to use recursion and memoization in some way, or implement DP. I'm not sure if iterative DP we will be able to implement on this question, but yeah, DP will be there. Okay, you have to do permutation and combination, like on first you have to buy on this, and you have to sell any one of this. Then you have to buy on this. Like with the use of recursion, you can implement this. When we'll get to those questions, we'll discuss how this works. Okay, but there is another way to implement this. With what I've used is called a max write array. By implementing max write array, or there is a term used for this. I am not able to recall it, but yeah, generally we create an extra array with an extra details just to calculate the solution values for this particular array. So what we have done here is, I am creating another array called max write array, which will be the same length as of our question array, same as this one. And for each of each of the places for those array, it will store the maximum value right of the particular element. For example, what are the maximum value of 4 right to the 4? There is nothing to the right to the 4, so the 4 itself is the maximum, so you'll store 4. For 6, what is the maximum to the right? It's 6 itself, you'll store 6. What is maximum to the right for 3? Both of these are larger than 3, but 6 is maximum, so you store 6. Then again 6, 6 and 7. Now, after storing that value, you'll get the future maximum value for each of the day that the stock will go in terms of question, and you can get the maximum profit for that particular day, or for the particular index that you can sell in future, by just subtracting this max array value and your original array. Okay, so this will be 7. 7 minus 7 will be 0, because you cannot make any greater profit, because all the other days are lower than 7. So maximum profit you'll be able to make is 0 by buying and selling on the same day. Okay. For 1, the maximum will be 6, because the maximum value on the right side is 6. So you can make 6 minus 1 equals to 5. Same for 5, 6 minus 5, 1. Similarly, you'll get a list of all the data, all the profits you can make according to the day, and you can just find the maximum value out of it, and you'll just return it. That will be your answer. That you can buy it on day 2 and sell it on day 5. Very easy implementation. This implementation is actually very easy as compared to the DP1. DP1, you have to learn dynamic programming, and then you have to have idea about recursion and memoization to optimize it. But this implementation is actually quite easy. Okay, and I'll just show you the code for that. So right, so this is the part where we are calculating the max write array values inside of max write array, and max write array is of same length. Initially, I'm filling it with 0, and I'm using a max variable. Max variable we traverse the max write array from right to left, because we need to keep track of the rightmost maximum element, right? So to keep track of the rightmost maximum element, I'm using the max variable. and which will keep track of the rightmost maximum. So the very first will be the rightmost value, and then it will keep comparing, like if the current value is greater than the max variable. If it is not, then it will if it is not, then it will keep the max variable same, and if any value at I is greater than max, then it will update the max to that value and store the that value at the same index in max, right, until the max value is updated again. And okay, after once we get the max right array, we can just simply compare the max right minus, we can simply find out what is the max value we can get out of max right minus price for each index I. So we'll just store that in the max, we'll be reusing the max variable and return the max in the end. So we'll get the maximum profit. Simple implementation, and it's not as because this is easy on the memory as well, because you don't have to implement recursion, or you don't have to create another you don't have to memorize it in some way. So it's a quite easy implementation. If we'll get time, we'll discuss the other DP way also someday, and we'll see. Okay, if we see some other variation of this question, we'll come back to this one and we'll discuss the DP format for this as well. Okay, okay, now let's move. Okay, this is the question for day 6, and this we did yesterday, because I'm shooting it on a Monday. Okay, so this is invert binary tree. Okay, for this you have to understand the implementation of binary tree. Actually, trees are very easy to understand. I'm not saying it is, and the concept of tree is very difficult, but you have to understand how whatever programming language that you use, right? You use JavaScript, Java, whatever you use, you need to understand how you implement trees. After that only you will be able to solve the question of trees. Okay, you need to understand trees are stored in a form of objects in which we have number of references. So for binary tree, we create an object, and object not specifically for binary tree, but for each binary tree node, and each node has two pointers for left and right, which will be pointing to the next nodes. That will be the left and right children for that particular node. Okay, so you need to understand the implementation of this first. We'll try to discuss it in some day in some video. I have some lack of infra and lack of facilities right now, and I am not able to create very high quality videos over this, and I'll try to improve this as much as I can in coming days. But yeah, um, then we can sit down someday and discuss about this. But yeah, right now you can just go into any website and any YouTube video, it is available. You can understand the implementation. You can use Chat GPT, and it's very easy right nowadays to understand any topic. Okay, so this once you understand how trees work, then you will understand right how traversal happens and whatnot. Okay, so it's actually very easy. Uh, you have two ways to solve this problem. You can start swapping elements from the root node itself. If you are at 4, you swap 2 and 7, and then you move to the lower node. So you 4 you swap 2 and 7, and then you go to 7 here, because after swapping 7 will come here, and then you go to 7, and inside 7 also you swap the children until you reach a node which does not have any children, which have both of them else. So you'll stop. Okay, so by that you can get your answer as well. But for me, any backtracking, whenever you're working with trees, you have to you have to traverse down the trees using recursion. And in recursion, backtracking is a easier solution to implement. So I have done that using backtracking. In backtracking, you do the same thing, but you do in a reverse manner. So instead of reversing it first, you just reach down to bottom of the tree first, and then you start reversing from there. So I'll traverse down at 1 here, then I'll try to reverse swap the children. It doesn't have any children, so I'll just go back and I'll go to 3. So I'll try to swap children. It doesn't have any children. I'll go back to 2. I'll try to swap children. I'll be able to swap because it has both of the children. So 3 will come here, 1 will come here. I'll go to 4 and I'll go to 7 because 7 the right child is still unvisited. And then I'll go to 6. Similar way, I'll try to swap. I'll try to swap here, and then I'll try to swap here. I'll swap here, and then finally I'll go to back to root and I'll swap the both of these elements. Then 7 will come here and 2 will come here, and then we'll have an answer. We'll return the root. So better implementation is backtracking, but yeah, other implementations all can also work. That's not an issue. One question can have multiple solutions. It's not like each question will have only single solution. Okay, so I'll just show you the code. Uh, invert binary tree, right? Yeah. So yeah, so this is the implementation. This is the implementation of binary tree in JavaScript. You can see, right? The tree node is an object which has the current value of the which has a variable for current value. This dot val stores the value of the node, actually 4 to 7, and we have two references to left and right children which actually point to different nodes, address of the different nodes. So here would be a reference to the different node itself, which will also be a tree node itself. Okay, so you can read about it. I'll try to cover this someday if I get chance, and if I have a better recording and better infra to shoot this kind of video, I'll definitely cover this. But yeah, you can definitely read about this. And here is the implementation of the same. We are traveling down the path to the left side first, and we are just recursively calling this function, which is the same, and we are going down to the left path. Once we reach here, we'll note that, right, the root is null now. We'll have to start our function will end with our base case, and we'll start the actual swapping. This way you have read about it, right? In the very first problem, you might have, when you started coding, you might have read you might have seen this kind of problem. You have two variables given, a and b, and you have to swap the values of a and b. So we use another variable c, and then we store the value in c, and then we swap in b, and then we store the value of c into b. Same way we are doing it here, but instead of swapping values, we are swapping pointers. So the left pointer is pointing to right, and right pointer is pointing to left. So our children are swapped off for each of the root node. Okay, and this return actually we don't need for each of these, because you can see, right, we are not storing this function call in any other variable. This is just a call. So for all of the calls within the function, within the operation, is not really using the return value. In the end, when the function ends, we have to return the root. In that case only, this particular return value is being utilized, and it is actually returning the root node after inverting all of the indices down there. Okay, after backtracking, when the backtracking ends. So yeah, that was it. So we started on Tuesday, and we were able to cover 6 questions in this week, and from next week onward, we'll be able to cover 7 questions per week. So these were the questions that we covered in this week. I'll definitely see you in the next weekly review. I'll be posting each reel daily again on Insta for each question that we'll solve daily. So yeah, stay tuned on both YouTube and Instagram. Bye guys.